Welcome back to this session. Let us take on a practical example now. As I told you, we want to be able to fit a straight line to our pendulum data. We'll do this using a least squares fit. So what did we have? We had a data file. This file gave us a plot, the values look like this, all scattered, and it looks like these values are all scattered nicely around a straight line. So this linear trend is visible. And what we want to do is, this is not a straight line. Can we actually plot one straight line that best fits this data? Essentially, this is what we want to do. Given these dots, we want to fit a line that fits this in the least squares sense. Now, this is a common problem that's solved in numerical methods. So, how do we do this? Well, we first need to formulate the problem cleanly. What do we want to do? Our equation is essentially of this form. We want something of the form t squared is some m into L plus C, because we are saying that L is proportional to t squared. So what we want to say is, okay, so t squared is some m times L plus some constant C. In a matrix form, this equation can be represented as some t squared is A into P, where P are the unknown constants m and C. So what do we have? We have experimental data which gives us t and L values. What we don't know is m and C. So we want to be able to fit a line. So how does this look in matrix form? Well, we have something like this. We have t squared, t1 squared, the first measurement, is some L1 into m plus some C. T2 squared is some L2 into m plus C, which is, this is exactly how it is written in matrix form. T1 squared equal to L1 m plus C. Because again, this is a matrix vector product, which means it's row L1 1 into MC, add those together. So it's L1m plus C, that is equal to T1 squared. Similarly, T2 squared is L2m plus C. So on and so forth, we have n values. In our case, we have 90 such values. The nice thing is, if I can write this in a matrix notation, it becomes very compact. So T squared is A dot P, where P is the unknown vector of m and C. We don't know the answer for this. So what we want to do is, we want to be able to find P, but we know T squared and we know the matrix A. So which means, if I multiply this by A inverse on both sides, I will get the P value. So how do we solve this? So this is how we solve this. So first, let us load this data. So this you have already done before, so please type this again. L comma T is load text, pendulum.text, unpack equals true. Then create T squared by simply multiplying T into T. Once again, you need to make sure you have the pendulum.txt file with you and make sure you are in that directory, otherwise you must supply the path to this directory or cd into that directory and run the same command. I hope you're done with this. Now, first thing we need to do is we need to generate the A matrix. If you remember the A matrix, it had all the L values in one side and 1 on the other side. So how do we do this? Well, it's easy. Look at this code. We say A is equal to array of, give it a list. This is the first row, L. So what we'll do is we'll create 2 rows. We know how to do that. So L is a set of all the 90 values. Then we do ones like L. So this is how ones like is very convenient. We don't have to create an array in a complicated way. We simply say ones like L and you'll get an array that is shaped exactly like L but has all ones. So please type this. Now we need the transpose of this. Remember, L is a row, 1 is also a row. We want it as columns. So we just do A is A dot transpose, A dot capital T. Are you done with this? Okay, now that we have the A matrix, we already have T squared. So what we need to do is we need to solve for P. Now the problem is, when I said before we have to invert A, obviously we can't invert A. Why can't we invert A? Because it's not a square matrix. So the only way you can solve this is to use a least squared approach. Turns out that there is a function already that does this for us. It's called LSTSQ. So just type the following: result equal to LSTSQ A comma T square. That is, given a matrix A and your right hand side, it will find the value of P for you. So have you typed this? Now notice that the result, just like your IG result, will give you two values. What you are getting here is the coefficients M and C, which is given as the first output. So least squares will give you a lot of things. It will give you the answer as well as many other quantities. To find out more, once again do LST question mark and you will find out more. But to get your answer, you simply need to get the first element of that, the first part of this. So now you get the coefficients. So now let us see how we can use these coefficients. So the first thing we want to do is, now we want to calculate that line. So how do you find the line? Well, we have all the L values. So we just calculate the T values, that is the T squared values, as coefficient 0 into L, which is M into L, plus constant, because L is linearly increasing. So let us try this. I will go back and repeat whatever you have done. So what did we say? We said L comma T is load text pendulum dot txt unpack equals true. Then I said TSQ is T star T. Then I say A is array open square bracket L ones like L close square bracket close. Now I have A. Now I say A is A transpose, remember from the formulation. Now I can say result equals LSTSQ A comma TSQ, which is T square. Now coefficients are result of 0. Let us see what the coefficients are. It says it's 4.141 whatever and 0.073, which means the slope is 4.14. So now I need to use the slope to generate that straight line that we needed. We already have the L values. So what are the L values? It's all of these values. So if I want to now create a straight line from this, notice that these points are nicely ordered. So I can either draw it with 2 points, starting with the lowest value of L, the highest value of L, multiply and then get those two coordinates. Or since these points are nicely ordered for us, I can find T line equals coefficient of 0 star L plus coefficient of 1. What does this do? So this will give me an array of values T. For each value of L, it will give me the corresponding T as corresponding to this straight line. So now if I simply plot it, I should get the desired answer, which is exactly what this does. T line is coefficient of 0 into L plus coefficient of 1, which is essentially ML plus C. Now if you plot it, you just do plot L comma T line. Let's do it. Plot L comma T line. Let us do it as we have done it there. We'll do it in red. That's our straight line, best fit straight line. The actual values are plot L comma T square, and let us plot it with blue dots or blue circles. And there we have our plot. Take you back to the slides to show you what we have done. T line is coefficient 0 into L plus coefficient of 1. This essentially gives you all of those points. Now there are many ways you can draw a straight line. In this case, we have drawn it with multiple lines joining each of the points. We could have also done it in a much simpler fashion, but this is an easy way of doing it. And now we just plotted the straight line L comma T line and L comma T squared. So you can see how easy it is to actually do a least squares fit with the tools that we have provided. Thank you very much.